Have you ever really stopped to think about how a tiny touch on your foot travels all the way to your brain in like a split second? Well, it turns out your body is crisscrossed with these amazing sensory superhighways, this incredibly intricate wiring that makes it all happen. And to really get a feel for just how specific this wiring is, we're going to start by trying to solve a real-life medical mystery. So let's dive right into a genuine neurological puzzle. It's the kind of thing that seems to completely defy logic. A single problem in one spot, creating symptoms on opposite sides of the body. The question is, how on earth is that even possible? Okay, so let's meet our patient. Get this, she's got numbness in her right leg, meaning she can't really feel things like pain or temperature. But then on her left leg, she has weakness and can't feel vibration. You see the problem here, right? A pain issue on the right and a vibration issue on the left. It's a total clinical head scratcher. Now, to solve this, you don't need to be a doctor. You just need to be a detective. The clues are all hidden right there in the body's own blueprint, in the very wiring of our sensory pathways. So let's ask the big question. How can one single point of damage create such a bizarre mix of symptoms? Well, the answer starts with a simple fact. Not all sensations travel on the same road. Our body uses two totally distinct sensory superhighways to shuttle information up to the brain. So let's get to know these two main information pipelines. So this diagram here shows the body's major communication lines, what we call long tracts. We're just going to focus on the two sensory pathways. See the blue one? That guy handles things like vibration. We're going to call that the PCML pathway. And then there's the orange one for pain and temperature, which is known as the anterolateral system, or ALS for short. And these two systems have very, very different jobs. You can think of the PCML system as our high-resolution pathway. It's for the fine details. You know, the vibration of your phone, knowing where your arm is without looking, the feeling of silk. The anterolateral system, on the other hand, that's our protective pathway. It's the one that's screaming, ouch, that's hot, or hey, that's sharp. It's all about pain, temperature, and just basic crude touch. All right, to crack our puzzle, we have to actually follow the signal. We're going to trace the journey of a sensation from the body all the way to the brain along each of these superhighways. And I'll give you a huge hint. The absolute most critical thing to watch for is where these pathways cross over to the other side of the body. That's everything. Let's start with the PCML, our high-res system. A signal for, say, fine touch enters the spinal cord. And as you can see from this blue line, it immediately heads north. It travels up the spinal cord on the exact same side it came in on. No crossing. Not yet. So the PCML signal cruises all the way up the spinal cord and only crosses over much, much higher up, right here in the lower part of the brainstem called the medulla. That's its crossover point. So its journey is almost entirely on one side before it finally makes the switch. Okay, now let's look at the orange line, our protective anterolateral system. A pain or temperature signal comes into the spinal cord and, whoa, look at that! It wastes absolutely no time. It crosses right over to the opposite side almost immediately, right there inside the spinal cord. And after making that super quick crossover, the signal then travels up the entire length of the spinal cord and brainstem on the opposite side from where it started. And this, right here, shows the fundamental difference between these two systems. It's just brilliant. So let's just nail this down. The crucial point is all right here. The PCML, for vibration and fine touch, crosses way up high in the medulla. The anterolateral system, for pain and temp, crosses way down low in the spinal cord. This one difference in wiring is the master key to our whole puzzle. Now, before we put it all together, there's one more incredible detail we have to talk about. These pathways aren't just random bundles of wires. They are meticulously organized, with a specific map of your entire body laid out along them. This organization is called somatotopy, which literally means body map. The easiest way to picture it is to imagine a little person or a homunculus mapped right onto the nerve fibers. As you can see here, signals from different body parts, your legs, your arms, your torso, they all have their own designated lanes on these neural highways. It's amazing. And this mapping is unbelievably specific. In one pathway, the leg fibers might be tucked on the inside and the arm fibers on the outside. But in the other pathway, it might be totally reversed. The main thing to get is that everything is sorted with incredible precision before it even arrives at the brain's central relay station. This level of organization is exactly what allows us to solve our patient's puzzle. Okay, we have all our clues.
We know the two pathways, we know their different jobs, and, most importantly, we know their different crossing points. It is time to go back to our 71-year-old patient and finally solve this thing.
Let's just walk through the logic. Step 1. Imagine a single point of damage, a lesion, on the left side of the spinal cord. Okay. Step 2. Now think about the pain signal coming from the right leg. Remember, that pain pathway crosses over right away, so its signal is already traveling up the left side of the cord when it runs smack into the lesion. The result? Numbness in the right leg. Now, step 3. Let's think about the vibration signal from the left leg. That pathway stays on the same side, remember? It travels up the left side and runs right into that same lesion before it ever gets a chance to cross. The result? Loss of vibration sense on the left leg. And there you have it. That is the solution to the entire mystery. One single lesion on the left side of the spinal cord explains everything. It caught the pain pathway after it had already crossed over from the right, and it caught the vibration pathway before it had a chance to cross over from the left. It's just a perfect demonstration of our body's incredibly precise and beautiful wiring. So the anatomical map we've seen is just remarkably precise, and it allows doctors to pinpoint problems with incredible accuracy. But what's really, truly mind-blowing is that this map isn't set in stone. The brain can and actually does redraw its own blueprint in response to injury or new experiences. And that just leaves us with a final question to chew on. What does it mean for our sense of self when the very map of our body can change?